Welcome back to my channel. Today I'll be discussing discontinuous page, that is discontinuous polyacrylamide gel electrophoresis in details. So as the name suggests, page, that is polyacrylamide gel electrophoresis. Acrylamide is the chemical which is used in the gel formation and to separate the mixture of the components. And basically there are two type of gel system as the diagram shows, a continuous gel system and a discontinuous gel system. So what is the difference between these two gel systems? In continuous gel system, what is there, that is there is a uniform concentration of acrylamide throughout the gel. Okay, uniform concentration of acrylamide. Okay, whereas in discontinuous system, gel system, there are two we can say the two portions of the gel, two different portions of gel which are formed with different concentrations of the acrylamide. These two portions, that is stacking gel and resolving gel. Okay, the second major difference between these two gel systems are that in continuous gel system the pH is throughout same, whereas in discontinuous gel system the pH variation is there, which we'll be learning in further slides. Now the next question is, why discontinuous, why not continuous? Basically what happens in continuous gel system, that is the resolution is very poor. Okay, the diffusion of the bands occurs in the continuous gel system, and hence with this discontinuous gel system with two types of gel, that is stacking and dissolving, there is a greater resolution of the bands. Okay, this is a diagram that is to show you what is the what are the result, the end points of continuous gel system on your left versus the discontinuous gel system on your right. As you can see, which I have already told, that in continuous gel system, when we are using continuous gel system to separate a mixture, okay, it results in a poorly resolved and diffused bands. Whereas if you can see on the right hand side, that is the discontinuous gel system end result, the bands are very crisp. Okay, it's very crisp and very greater resolution in comparison to that of continuous gel system. Okay, buffer systems. Now I already told you that is discontinuous gel system. Buffer systems, that is stacking and resolving gel, are made up of two different type of pH, that is 6.8 and 8.8 respectively, which I have spoken. Okay, there are two type of buffer systems, running buffer and gel buffer. Gel buffer further classified as stacking gel buffer and separating gel buffer. Okay, now the next question here is, why do we need a stacking gel? Why do we need a gel with large pore size and less pH? What is the function of this stacking gel? Basically the function of this stacking gel is to, it results in the stacking, it results in the stack of that, we can say the mixture. It stacks it, it narrow down into a small portions. Okay, it stacks the sample into narrow zone, resulting in a sharpness and resolution of bands. That is the advantage of having a stacking gel. Next is basically this is a diagram which is depicting the different buffers or using different pH. The stacking gel is having 6.8, whereas the resolving gel buffer is 8.8 and the running buffer is having pH 8.3. Okay, next is the buffer systems, and there are basically two type of anions which are usually present in the discontinuous gel system, and these are mobile anions. And in running buffer, glycine anion is present, whereas in gel buffer, that is chloride anion is present. Okay, and so I have told you the basics, the buffer system, what is the use of stacking gel, why do we need it. The next question here is mechanism of this discontinuous gel system. I'll be giving an overview of this mechanism in this vlog. And basically we know that depending upon the pH, the glycine can be present in three charged states. Okay, at low pH, the glycine is present in the positive charge state, and whereas at isoelectric point, that is Pi, it is present in a neutral charge state, and usually it is also termed as butyronic stage. And at high pH, the glycine is present in a positive charged state. The glycine molecule in the running buffer, which is having pH 8.3, predominantly exists in two forms, that is in the neutral form and in the positively charged form. So when the voltage is applied, what happens? These glycine molecules, they are forced to enter the stacking gel. The light gray is the stacking gel and the dark one represents the separating gel. Okay, and this red I have marked the sample, the protein sample. Okay, and when I apply a voltage, the glycine molecules which were existing in zwitterionic or in a positively charged state in the running buffer, they enter the stacking gel. And while entering the stacking gel, it comes across to a pH that is 6.8. So let me tell you one thing, that the isoelectric point of glycine is 6.7, and hence due to this overlapping of the pH, that is the stacking gel pH being 6.8, the glycine molecules which are existing in a positively charged state or in a zwitterionic state, they predominantly now exist in zwitterionic stage due to this pH. Due to this neutral state of these glycine molecules, the mobility of this anion in the stacking gel will be very less in comparison to other molecules which I'll be discussing later. Okay, that is, it is just in zwitterionic state. Due to this neutral state of that, in the presence of electric field, the mobility of this anion will be very less. I already told you in the previous slide that there are two anions, glycine, which I've already discussed, and that is the next is the chloride ion, which is present in the stacking gel. The mobility of this chloride anion is very fast in comparison to the protein sample as well as to the glycine which has entered into the stacking gel, as a result of which the mobility of chloride ions will be maximum. Then comes the protein sample, then comes my glycine molecules. Okay, and hence in this stacking gel, what happens, the protein sample which I wish to separate, it is sandwiched between the fast moving chloride ions and the trailing ions, which are the glycine ions in this stacking gel. When these protein mixture, it comes to the borderline of my stacking and my resolving gel, what happens, these protein sample, they come face to face to the high concentration of acrylamide and high pH. Due to this high concentration of acrylamide, the protein samples are impeded. The sieving effects come into play. Okay, another thing, what happens when they come across this resolving gel, the glycine predominantly now exists in anionic form, in negatively charged form, due to the high pH, as a result of which this glycine molecules, they overpass these impeded protein which are present in the borderline of these two gels, and overpassing them and come in the upfront of these molecules. Okay, now the mobility is the chloride ions are having greater mobility, followed by the glycine ions, and then the my proteins. Okay, the increase in acrylamide concentration in the resolving gel, it helps, I can say it resolves these protein mixture according to the molecular weight, and as a result of which my mixture, which I wish to resolve using polyacrylamide gel electrophoresis with discontinuous gel system, I get my resolved protein mixture into discrete bands according to their molecular weight. Thank you so much for watching my channel. Please like, subscribe and share and comment below any question.